Hello everyone, welcome back to the channel, and today we are diving into the multi-class classification using the Fashion MNIST dataset using TensorFlow and Keras. Okay, so first we need to import our packages, right? So let's import. And before that, what is multi-class classification? Where you have to predict like multiple class for the output, like by scanning an image, we might have to predict that is it a dog or a cat or a bird, right? This kind of prediction. And in this code, we'll be predicting that there will be a multiple images, and you have to predict that what kind of fashion fashion things is that. Okay, so first we need to import our packages. So for that we'll import TensorFlow as TF, and from TensorFlow, as Keras comes with TensorFlow, so we need to import Keras from TensorFlow. Then we'll import numpy as np, then we'll import matplotlib dot pyplot as plt. Okay, then let's run this cell. Okay, then we have to load our data. Okay, so wait a minute. Okay, so Fashion MNIST dataset comes with Keras library, so we just have to take that from Keras. So simply in a variable, I'll keep it like say Fashion MNIST p from Keras dot datasets. I'll use Fashion MNIST. Okay, and here I'll simply break it into train and test dataset, because as I said, this dataset is already comes with a pre-planned training and tested fashion. So x train, y train, and x test, y test. Then simply I'll load the data. Okay, so all right, we have loaded our data. Now it's time to visualize the dataset. So for that, and before visualizing, let's see what we have in our training and what we have in our testing. Okay, so for that we'll print xtrain dot shape and ytrain dot shape, and also let's see our test case. So x test dot shape and y test dot shape. Okay, let's run this both, and you'd see that we have 60,000 with 28x28 pixel size of xtrain and 10,000 images of 28x into 20x of images. Okay, and in prediction we have 60,000 prediction, and here we have 10,000 predictions. Now it's time to visualize the data. So for that, in this particular Fashion MNIST set, we have around multiple classes, right, as we have discussed earlier. So in the class names, we'll name each and every classes. So we have t-shirt or top, we have trouser, we have pullover, we have dress, we have coat, we have it will be sandal, and of course shirt, and we have sneaker, bag, and ankle boot. Okay, now we need to plot these things. Let's say I'll use a figure size of how much, 10x10. Then I'll run a loop for I in range 25. Plot dot soft plot, say 5 comma 5 comma with I plus 1 iteration with dot x ticks in an empty array. Then y ticks also in an empty array. Then simply we have to plot in a grid, so grid false, and in plot I am sure we simply need to pass our train, and cmap will use binary x level class names. Here we need to pass our predicted values, right, like y train. After that simply we'll plot and show. Let's run this, and yeah, you see we have this many types of features. So we have ankle boot, t-shirts, dresses, pullovers, sandals, then trousers, coat, bags, dresses, all those things. Okay, so now our next step would be process our data. So let's do it. For that, what we will do, we'll here the process means we have to normalize the data, because generally neural network works best when we normalize our data. Okay, so we will normalize here with divided all of those with 255. Okay, let's run this. So what it will do, it will convert our pixel value from 0 to 25, so from 0 to 255, and it will convert these values into 0 to 1 for our better training purposes. Now we need to build our model. For that we'll write this model variable. Here in Keras we'll use our sequential API. Then simply we need to create one by one the layers. So the input layers, we need to flatten our pixels. So we'll flatten, what will flatten? Our input shape of 28 and 28. Okay, then in the next step we'll create our hidden layer. So hidden layers dot, we'll use our dense function. We'll use 128 neurons. With activation function, of course, we'll be using ReLU. And for output, we'll use 10 neurons, and activation function will be using activation function will be using softmax, because you should know that softmax is basically used for classification problems. Okay, now let's run our model. Okay, so I don't need this. So model is done. Now it's time to compile the model. To compile, our simple syntax would be model dot, we need to simply compile it. Compile, we need to mention our optimizer, right? So we'll be using Atom optimizer. Then for the loss I'll be using sparse categorical, because for the last one in the binary classification we have used binary coarse entropy, and here as we have multiple classes, so we have to use sparse categorical coarse entropy. And then after this we'll be using this matrix of accuracy. Okay, let's run this. Okay, there will be some error. It says, okay, Adam. All right. Now it's time to train our model. For train, we'll use simply the fit function. So model.fit will pass xtrain comma ytrain with epochs. I'll be giving it, let's say, how much? Let's say 20 epoch with validation data. For validation purpose, I have my tested data, right? So I'll give x test and y test, and let's run this. So it will run, and it will also show me the accuracy and loss as per each epoch. So it will train now. So till it's training, let me write my evaluation function, right? So in evaluation, what we can write, we have to figure out our test losses. So test loss and test accuracy. For that, we'll use evaluate function. So evaluate will pass our test parameters x test and y test. Then simply we can print our accuracy. Okay, and it has done only 9 now, so just wait for a couple of seconds. So as per the 10 epoch, we have already reached 91% of accuracy. Okay, so let's wait if we can reach up to 95. All right, so we have finally reached up to 93% of accuracy. Okay, so let's print the accuracy here. So the accuracy is around 87 for the test, right? Because we are evaluating this in our testing. So you see 87% for the test results. Okay, now it's time to predict our code. So for that, I'll use predictions variable. Here I'll simply call predict, right? Predict my x test, then I'll print this. I'll print, let's say, np dot argmax of argument max predictions. I'll do the first prediction. Okay, and then I also need to print the actual one. So x test 0. Okay, so we have 9 of actual test, and for the prediction we also have 9. So we have predicted all the test values. Now I need to plot it to show. So I am show use x test 0. We'll use a cmap, and you'll use dot binary and then dot x level predicted class this, and also I need to use class names of at least y trends of 0th index. And then finally we simply need to plot.show, and it will show us the predicted picture. So we are predicting with the ankle boot, and the predicted one is ankle boot, and it's actually an ankle boot. Okay, and that's it. We have successfully trained a deep learning model to classify a Fashion MNIST images using TensorFlow. So if you have found this video helpful, don't forget to like and subscribe. And yeah, thanks for watching.